This is Unit 2, Notes 9. The topic is monomials. Go ahead and get that labeled at the top of your paper. So a monomial is a number, a variable, or a product of a number and variable. It could also be more than one variable, which is why I'm putting that S in parentheses. What this means right here is that you have like 9 times X times Y. Right? A number would just be a number, a variable would just be a letter, but a product of a number and a variable or variables, an example would be 9 times X times Y. Okay, so let's go ahead and think on your own of just some examples and go ahead and write a few down. So a number would be 5, a variable could be negative 6x, or it could just be y, or it could be negative 11x squared. These are all monomials. So now monomials with the same variables and same exponents, those are called like terms, which we already know. So in my examples above, I don't have any like terms because yes, these both have an x, but this is x squared and that is not x squared. So they are not like terms. Right, so to add or subtract monomials, all you have to do is combine like terms. Super simple since we've been doing it already. When you combine like terms, remember you do not change the variables or the exponents, the numbers. That is all that will change. So take a look at number 1. We have 3x squared plus 8x squared. X squared and x squared, that's the same variable. So we can combine. All we have to do is 3 plus 8, which is 11. And our answer is 11x squared. This is very similar to what we've been doing, but now we're just throwing some exponents and different things in there. So we have negative 7x minus x. Those are like terms because they both just have an x. Remember, if you minus x, it's just minusing 1x. So we're going to do negative 7 minus 1, which equals negative 8. And our answer is negative 8x because don't forget you need that x. Go ahead and try numbers 3 and 4 on your own. All right, number 3, you should have done 9 minus 14, which is negative 5. And then our like term was y cubed. Number 4, recognize that we are subtracting a negative, which is the same thing as adding. So we have negative 2 plus 4. That's going to get us positive 2, and then our variable was x. All right, now number 5 seems complicated, but it's not. Let's look at the variable. Our variable is x squared y and x squared y. So that's not going to change. X squared y will stay. Again, we're just looking at the coefficients or the numbers. We have negative 7 plus 10, which gets you positive 3. So our answer is 3x squared y. Go ahead and try number 6 on your own, and remember that subtracting that negative right there is the same thing as adding. Okay, you should have done 14 plus 5, which is 19, and then our variable term with x, y, z. And that's our answer. So adding is super easy because all you have to do is combine like terms, which we've already practiced and know how to do. So go ahead and flip onto the back. And let's talk about when you multiply monomials. Wait, did we skip? Okay. So to multiply monomials, you're going to use the product rule, which says that x to the power of a times x to the power of b equals x a plus b. And that might sound confusing, but it's not. So I'm just going to write this note at the top that says, when multiplying terms, you add your exponents. And we'll see what that looks like down below. So find each product, remember that means to multiply, and express your final answers using exponents. So we're not solving, we are keeping our exponents there, and then we're going to stop. So we have 3 to the power of 3 times 3 to the power of 4. If we look up here at our product rule at the top, it says that our base, which in this case is 3, remember your base is the big number, stays the same. So we have 3. And then what happens to our exponents? If we're multiplying the bases, we add. So we have 3 plus 4. So that's going to be 3 to the power of 7. And yes, we could solve that, but we're just trying to figure out how to work with exponents right now. All right, so go ahead and try number 18, 19 on your own. So pause here. All right, so for number 18, you should have had -4. Remember, when it's a negative, you need to put that in parentheses. And we should have done 2 plus 8, which equals 10. So our new exponent is 10. Number 19, our base is 8. We add our exponents together to get 5. So our new exponent is 8 to the power of 5. All right, so let's do it when our bases are variables instead of constants. So number 23 says x to the power of 12 times x to the power of 2. So still our base will stay the same, it's x, and we're just adding our exponents. So our answer is x to the power of 14. Go ahead and pause and try number 24 and 25 on your own. For 24, you should have gotten y to the power of 12, and you should have here had p to the power of 7. Now I say 7 because this p right here did not have an exponent, so you can just assume that it's 1. So you should have done 1 plus 6 to get 7. All right, number 26. This one's a little bit trickier because you need to do the variables separately here. Right, it says x times y squared times x times y to the power of 5. So let's do our base of x times our base of y. So for x, what are our exponents that we're adding? It's just going to be 1. We can't see them, but it's 1. So we have 1 plus 1, which equals 2. So we have x squared. And then for y, this one's easy because we see the numbers. We have 2 plus 5, which equals 7. So it's 7. So our answer is x squared times y to the power of 7, or just x squared y to the 7th power. Go ahead and try numbers 27 and 28 on your own, so pause here. Okay, you should have paused and gotten 27 and 28. For 27, you should have had m, 7, n, and 5 to the power of 5. Right, I added my 2 and my 5 together for m, and then I added my 2 and my 3 together for n. Number 28, you should have had x to the power of 4, y to the power of 8. And for x, you had to do 1 plus 3, and for y, you had to do 1 plus 7. If you have any questions, pause here, ask for help. All right, so now let's move on. we're going to put everything together. Let's do some examples where we have coefficients with our variables. All you have to do is multiply the coefficients. Remember, coefficients, that just means to multiply the numbers that you see. Then you'll simplify using the product rule, which is what we just did above. So if we have 12m cubed times 4m cubed, all you have to do is do 12 times 4, which equals 48. And then you use our product rule to figure out our exponent for a variable. So we have m cubed times m cubed times m cubed. So that equals m to the power of 6. Remember, we did 3 plus 3. So our final answer is just going to be 48 m to the power of 6. Go ahead and try number 30 on your own. Pause here. All right, you should have done 30. First, we'll do -2 times negative, oops, that's supposed to be a 4, -4. That's going to get you positive 8, so that is our coefficient. Then you have v to the power of 9 times v to the power of 2. So we do 9 plus 2, so that we get v to the power of 11. Let's go on to number 32. We have negative x to the power of 7, y to the power of 4, multiplied by negative 2x squared, y to the power of 3. A lot is happening here, but you can just break it up step by step. So let's do, remember, this is like negative 1x. So we can do -1 times -2, which equals positive 2. Now we can do x to the 7th times x squared. Remember, you're just looking at the coefficients that have the same base. So x's go together and y's go together. So x to the power of 7 times x squared equals x to the power of 9, because 7 plus 2. And then we have y to the power of 4, y to the power of 3, so it's going to give us y to the power of 7. All you have to do is everything separately, and you'll get your answer. Go ahead and try number 33 on your own. Okay, number 33, should have multiplied your coefficients, so you would get 27. Our next variable, d, you should have had d to the power of 9. And our last variable, e, you should have e to the power of 11. All right. Now let's go ahead and try number 35. It says write an expression that can be used to represent the area of a triangle with a base of 4x squared and a height of 8x to the power of 4. So first, we got to figure out what's the area of a triangle. Well, we know, or we should know, that the area of a triangle is 1/2 times base times height. Now all we have to do is plug those values in. 1/2 is just 1/2 times base, which they tell us is 4x squared, and times height, which they tell us is 8x to the power of 4. So we can simplify this. We have to multiply all of our coefficients. So we have 1/2 times 4 times 8. That's going to give you 16. So we're going to write 16. Now if we do x squared times x to the power of 4, that'll give us x to the power of 6. So this would be our area. Now we don't know what x is, so we just leave it at that. Go ahead and try number 36. Remember that the area of a square is just length times width, or since they're the same length and the same width, you just do side times side, which just equals side squared. All right, you should have done number 36 on your own. Pause now if you didn't and fill that out. So express the area of a square with 4x side lengths as a monomial. So we know that it's side squared, and the side is 4x. Now we have to do 4x times 4x, which is going to be this entire thing squared. If you put 4x squared That's not correct because here you're just squaring the x. You need to also square the 4. So we don't want to do that. We want to do what I just did. So 4x squared equals 4x times 4x. So that is going to get us 16x squared.